Hola, algebra students. Today we are going to talk about another type of factoring, the difference of two perfect squares. Now remember, factoring means to rewrite something in terms of multiplication. So what we're first going to do is practice what we are supposed to know about how to multiply two binomials, and then we'll use that to work backwards. So the last lesson that we did was factoring out a GCF, and that's always the first thing you check for. But we're going to move on to a different kind of factoring, and we will go back to GCF as we get later on into the unit. So we're going to look at each of the different types of factoring before we start mixing them together. So yesterday was GCF. Today is DPS, for difference of perfect squares. Now difference means subtraction. Perfect squares means it's something times itself. So we're going to see what that means as we go out through this lesson. But first, as a review and a warm-up, I want you to use the box method to multiply the binomial x plus 2 times the other binomial x minus 2. So multiply those two together using the box method. Now if you remember correctly, this is called a binomial because it has two terms. That's the prefix bi, like a bicycle has two wheels. Okay? So binoculars have two eyepieces. Binomial have two terms. So x plus 2 is a binomial. The x and the plus 2 are the two terms. And then the other one, x minus 2, is also a binomial because the x and the negative 2 are the two terms. So as we multiply these together, the box method is basically doing kind of like a multiplication table of the terms from each parentheses. So that means I do x times x to get x squared, and then x times 2 to get a positive 2x, and then x times negative 2 to get a negative 2x, and then positive 2 times negative 2 to make a negative 4. So when we did this back in November, what we were supposed to do after we multiplied and filled in the pieces of the box, we are supposed to combine like terms. Well, the x squared kind of stands alone. It's the only piece that has an x squared. But then we have a positive 2x and a negative 2x here in the middle two boxes. And then at the end there's a negative 4. Those middle two terms, the plus 2x and the minus 2x, they cancel out to be 0. So I'm left with the x squared and the negative 4. The middle two terms cancel out. What happened to the middle two terms by multiplying times conjugates? They cancel out because they add to 0. If you want to put because they subtract to 0, that's fine, but you're adding a negative or subtraction. Now the special term for x plus 2 and x minus 2 is called conjugates. Okay? Conjugates are two terms that are the same numbers but opposite signs, plus 2 and minus 2. So it's two binomials that are the same numbers, but in one parentheses it's a plus, the other parentheses is a minus. So another example of a pair of conjugates would be m plus 8 and m minus 8. Those are conjugates because they're the same number, but one's positive, one's negative. Another example would be k plus 12 and k minus 12. Those are conjugates because it's the same number, 12 and 12, but one's positive, one's negative. Another example, it could be y minus 3 and y plus 3. The order doesn't matter, which one's the plus and which one's the minus and which one's first and which one's second. That doesn't matter. But it's the same number where one of them is a negative, the subtraction, one of them is a positive, the adding. So when you multiply two conjugates together, because it's the same number but opposite symbols, one's positive, one's negative, they will always cancel out. Okay? The remaining two terms, the x squared and the negative 4, the remaining two numbers, the reason why they are special is because they are perfect squares. X squared comes from x times x, and 4 comes from 2 times 2. Now the reason why it's negative 4 is because it was a positive 2 in one parentheses and a negative 2 in the other parentheses. That's why they were conjugates, and that's why they canceled out. So if we try to think about how we could use this to work backwards and factor, what we're trying to do is figure out, okay, what values would multiply to be the number that's left over, and since there's no value in the middle, they would have to cancel out, which means it has to be the same number. So what number squared is equal to 9 for this next example? And whatever it's going to be, remember that it's x of x to make the x squared. One's positive, one's negative. That's how they multiply to be a negative number. And they have to subtract out to be 0, which means it has to be the same number. So what number squared is 9? Or what's the square root of 9? That would be 3 and 3. Those would be the conjugates that would make x squared minus 9. An x plus 3 and an x minus 3. Let's see what happens if they were both positive. And this is something that we did earlier in the year. X plus 2 times x plus 2. That technically could be written as x plus 2 squared because it's the exact same thing in both parentheses. We cannot do that if one of them's plus and one of them's minus because it is not the exact same thing in both parentheses. So it doesn't quite work the same. So when we multiply this out using our table, x times x is x squared. X times 2 is a positive 2x. X times 2 is another positive 2x. 2 times 2 is a positive 4. So what happens here is we get x squared, and then the plus 2x make a plus 4x. And the positive 2 and the positive 2 multiplied to be a positive 4. So what happened to the middle terms? They got added together. They added together to make a positive 4x. They didn't disappear that time because it was both the same number and the same sign. What happens if I have x minus 2 and x minus 2? So let's see what happens if it's two subtractions, two minuses. X times x is x squared. X times negative 2 is negative 2x. X times negative 2 is another negative 2x. And then a negative 2 times a negative 2 makes it a positive 4. Combining like terms, there's only one x squared. Negative 2 and negative 2 add together to be negative 4. And we have a plus 4 at the end. Negative 2x minus 2 more is negative 4x. So what happened to the middle terms? These ones added to make a negative 4, but they were still added together. They just added to make a negative because they were both negative. So those are not conjugates. If we go back to the idea of conjugates, same number in both parentheses, but one of them is positive and one of them is negative, what's going to happen when we multiply and fill out our table? Well, x times x is x squared. X times 5 is 5x. X times negative 5 is negative 5x. And negative 5 times a positive 5 is negative 25. So combining like terms, there's only one x squared. The plus 5x and the minus 5x cancel out and disappear, so we are left with x squared minus 25. What happened to the middle terms when multiplying conjugates? Every time they were going to cancel out. They're going to add up to 0. And what's special about the two remaining terms? They're perfect squares. So the type of factoring this is called is the difference, subtraction, is sometimes called difference of two perfect squares. So that's why it's difference of perfect squares, because we are subtracting two perfect squares. So when working backwards, if you recognize that you have two perfect squares, with subtraction in between, as long as all that information falls into place, two perfect squares with subtraction in between, then you know it's a difference, so the subtraction part, of perfect squares, the perfect square part. So that splits the same in both parentheses, but one of them's plus, one of them's minus. What you need to do is mental math, figure out, or go to your calculator and determine what number times itself makes a 16. What number squared is 16? Which means on the calculator you would look for the square root of 16, so that is 4 and 4. So for any generic difference of two perfect squares, that's a subtraction sign in between two perfect squares, your factored parentheses will be a plus b, a minus b. Same every time. The square root of a squared is a and a. The square root of b squared makes it b and b. If there are numbers there, you do the square root of the number. If there are letters there, you just divide the exponents by 2 and split them evenly between the two parentheses. So let's do some examples here. T squared minus 81. It is subtraction, and these are both perfect squares. Now, if you need the list of perfect squares, I'm going to take a minute and write these out. So, perfect squares. 1 times 1 is 1. 2 times 2, or 2 squared, is 4. 3 squared, 3 times 3 is 9. 4 times 4 is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 times 9 is 81. 10 squared is 100. 11 squared is 121. 12 squared is 144. 13 squared is 169. 14 squared is 196. 15 squared is 225. 16 squared is 256. We usually don't go much higher than that. You can always do the square root of whatever number you're trying to find the square root of, and you can use your calculator if it's a number too big or a number that you just don't recognize. So you can test to make sure it is a perfect square. So here, t squared minus 81. 81 is a perfect square. So this is going to split exactly the same in both parentheses, except one's a plus, one's a minus. And then the square root of 81, or what number times itself is 81, would be 9. So t plus 9, t minus 9. It doesn't matter the order. Here, the variable went first minus the perfect square number. Here, the perfect square number goes first minus the variable. That doesn't matter. Just keep your answer in the same order as how it was listed originally. So here, the number goes first, and then it's plus b minus b. So whatever is subtracted gets the plus and minus sign, goes second. When we start mixing numbers and variables together, you're just going to split each one equally between the two parentheses. So the square root of 4 is 2 and 2. Square root of x squared, that splits evenly into x and x. And then the 9 split perfectly into a plus 3 and a minus 3. So you just do it the same. X squared minus 4. Okay, so the exponent here is an even number. As long as it's an even number, it can be split equally between the two parentheses. So you just do x squared and x squared. That way it's the same. And the exponents must add up to equal the original. The exponent of 2 plus the exponent of 2 equals the exponent of 4. So the exponents add up to equal the original exponent. The number, do the square root of 4, positive 2 on one end, negative 2 on the other end. Okay, 121h squared minus 36k squared. Looks like there's a lot of stuff here, but we're going to do it the same way. Square root of 121 is 11. And then you do half the exponent in the first parentheses and half the exponent in the second parentheses. Square root of 36 is 6. So plus 6k minus 6k. Remember that the exponents get split equally between the first parentheses and the second parentheses. That means for letter F here, we're going to have x to the third and x to the third at the front of each parentheses. That takes the 6 and splits it equally, 3 and 3. And then the square root of 49 is 7, so we have a plus 7 in one parentheses and a minus 7 in the other. And if you want to put the minus first, that's fine. That's not going to change the answer. So why don't you pause, try these examples, and then come back. All right, so this would be y plus 1, y minus 1. And then this one would be 3w plus 10c, and then 3w minus 10c. And then this would be a to the third minus b to the fifth, and then a to the third plus b to the fifth. Now I wrote the minus first just to show you that it doesn't matter which order you put it in. All of my other examples I did the plus first and the minus second. That's just the habit that I've gotten into by doing these for years and years. This one, letter D, looks a little weird, but the x minus 5 squared means there's an x minus 5 in both parentheses. And then there's the plus b to the fourth and the minus b to the fourth. Looks a little strange, but it's still done the same way. Now sometimes after we factor this the first time, it can be done even more. So r squared plus 4x squared, and then r squared minus 4x squared. Notice in the second parentheses, it's the difference of two perfect squares again. So when you write your final answer, you'll bring down the r squared plus 4x squared. We can never factor with the 2 there. That's not going to do anything. Or I'm sorry, with the plus sign. With a plus sign in between our perfect squares, there's nothing we can do. Because in order for our terms to cancel out and disappear, it has to be subtraction. So r squared minus 4x squared is a perfect square. So it can be broken down into r and r, and then plus 2x and minus 2x. So your final answer would be all 3 parentheses. You need to make sure you do all the parentheses in your final answer. Carry the one that has the plus sign and rewrite it. You have to rewrite it with your final answer to include all the different parts. So for letter F, I told you that the very first thing we're always supposed to check for is the GCF. What's the GCF here? That's right, it's a 2. So if we factor out a 2, which means divide a 2 out of both of the original terms, what's left over inside the parentheses is an x squared minus 9. That is the difference between two perfect squares. That's the DPS. So this can factor, again, keeping the 2 from the GCF. The x squared minus 9 can be factored into x and x, and then the negative 9 comes from a positive 3 times a negative 3. That is your final factor form, including the 2. All right, last one. Will x squared plus 4 factor? And the answer is no. And if you're going too fast, you're going to make that mistake. No, because the perfect squares are being added, not subtracted. This DPS factoring method only works if you're multiplying conjugates, which means you have a positive value in one parentheses, like the positive 3 here, and a negative value in the other parentheses. And when we do the box method and multiply these out, the positive times the negative will always lead to a negative result in between the two perfect squares. Has to be negative. So with the positive there, does not factor. And we are done in less than 10 minutes. Half the time of a normal class period. Be safe, take care, and I'll see you soon.